Welcome to Frequency Matters, the RF and microwave update. I'm Pat Hindle, and I'm here with my co-host Gary Lerude. In this episode, we thought we'd cover our June Diamond Anniversary issue as we celebrate our 60th year in publishing, a big accomplishment.
Yeah, amazing.
So we have a special report that talks about companies and organizations that are celebrating their 60th, and that's Gore, Rosenberger, NASA, and DARPA, and also ourselves. And then we continue the diamond theme with our cover story, and we talk about how diamond materials are used in microwave applications. And there are kind of three areas that we cover: GaN on diamond, diamond passives, and diamond materials used in packaging. So it's a very interesting cover story.
Yeah, that article came out really well.
We also have a special cover for our June issue. If you scan it with the Augmented Reality Layer app, that's L-A-Y-A-R, you'll get a cool animation about the innovators in wireless technology. We can take a quick look at a clip from that now. So Gary, what did we have for other technical articles?
Well, we have two other technical articles in the issue. One is an interesting GaN power amplifier design paper on covering a broad band from basically 1.5 gigahertz up to 2.8 gigahertz. So this 10-watt power amplifier can really cover all the cellular bands, and it would be a good application for small cells. And that was done by Ceres Technology. And then we have an interesting application note from Mori Microwave on the challenge of doing on-wafer load pull at millimeter wave. And of course, the challenge there is trying to get closed contours for the design. So the way they approach that is with a hybrid active system, and have some good results on that. So how about product features?
So we had a 1.8 kilowatt L-band GaN transistor from Qorvo's. I think that's one of the highest power solid-state devices we've seen. And we also have 50% faster digitizers from Spectrum Instrumentation. And then we had three tech briefs, right?
Right. The tech briefs are basically a compact, light wave RF peak power meter from Booten. We have low PIM surge arresters from Polyphaser, and an interesting 100 milliwatt, 40 to 60 gigahertz power amplifier from SpaceX Labs.
And so we have a special guest in the studio today, Tony Fischetti from MACOM. He's their vice president and chief architect, and we discussed phased arrays with him. Let's take a look at a clip from that. So Tony, tell us a little bit about this right here.
So this is MACOM's 5G sub-6 gigahertz base station antenna, which is a byproduct of our MPAR design and is also a digital to the element version of the MPAR antenna using all MACOM semiconductors.
Can you talk a little bit about the innovations that you've introduced with this architecture for those of us that may be more familiar with a brick style?
The salient architectural point of this antenna is to remain planar, meaning that there is no slat or brick style into the construction. Everything is planar to the back of the radiating face or the aperture, and all of the electronics required to support the RF-TR module are all contained within highly integrated MMICs on the back of the antenna, again keeping it into a planar configuration.
So we've seen a lot of these planar configurations commercializing phased array. How does that drive down the cost and still keep the performance?
So one of the main aspects of driving the cost down is removing as many of the connectors as possible. By going into a planar configuration, we can then build the array in a printed circuit board style, which means we can do complete surface mount onto the back of the aperture board and contain all of the analog combining and manifolding, if you will, all within the aperture board itself. And also bringing all the voltage regulation and all of the capacitance down onto the back of the board will allow a single voltage to come in and be fanned out within the board. So driving out the connectors, driving out the complexity of cable harness, and truly keeping it planar allows us to have a very compact airflow design.
It's always good to talk to Tony because he has a really unique perspective on the architecture of phased arrays.
Right, and it's interesting that MACOM is doing some things there. They're kind of climbing up the food chain.
Yeah, full system.
Right.
So Gary and I were recently at IMS 2018 in Philadelphia, and I tell you, as editors, we really work hard. I mean, all day, all night.
Right, up early, go to bed late.
As editors, we really work. Wait a second, those aren't the pictures I picked out.
I hope I'm not in any of those.
all kidding aside, there were some interesting themes there. Of course, 5G was widely discussed.
Right.
And I think the most interesting thing is how people are really commercializing phased array technology. You have an all-silicon approach from companies like IDT and Anokiwave, and you have a mixed approach from Qorvo, ADI, NXP, Infineon, and there's probably a few others. So it's very interesting to see which architecture and which mix of technologies will work out there.
Yeah, and in addition to, of course, all the buzz about 5G, I think all the other markets are pretty strong. We're seeing some interesting applications in the industrial side, and of course, defense remains strong with a lot of GaN insertions into phased array systems on the defense side. So I think all in all, it was an excellent conference this year.
Yeah, I think the one product that stood out to me was Synergy Microwave. They had an electro-optical oscillator-based synthesizer. They were playing at 20 to 30 gigahertz, but they could go up to 200 gigahertz. And it gives them both close-in, low-phase noise and far-out from the carrier. So it's a very interesting product.
Yeah, I went by the booth as well and got a demonstration of it. It is very interesting.
So any other trends you saw there? Or?
Well, I think there was a good turnout, as we've talked about, and a lot of buzz about 5G as well. And I think there were some interesting semiconductor results from some of the smaller companies. A lot of products being released, and I would think that market is starting to get saturated, but apparently not.
Never ending.
Never ending. Before we end the episode, I'd like to mention, as you know, that registration for our EDICon USA show is open now, so you can register. That's going to come up October 17th and 18th. It's a Wednesday and Thursday. And this year, instead of Boston, we're holding it in Santa Clara, California at the Santa Clara Convention Center, which is right in the heart of Silicon Valley. So we're in the process right now of doing the paper reviews, and so within the next month, we'll have the conference papers published. But in the meantime, you can get a head start and register for the conference, and we encourage you to do so. And you can go to ediconusa.com to do that. And I think that's a wrap.
It is.
I want to thank you for watching, and we want to thank our sponsor for this episode, MACOM. They're your partner from RF to Light.